Actuators. It is the component of any machine that is responsible for moving and controlling the mechanism. Over here, it is a robot, typically a serial or parallel robot in the industry. It is used to move the links of a robotic arm, fingers of a gripper, wheels of a mobile robot, propellers of an aerial vehicle like a quadrotor or a drone. It requires a control signal corresponding to the position, velocity, acceleration or the joint torque commands and a source of energy. In the figure shown below, the power supplies block mainly refers to the energy that can be supplied from an electric, hydraulic or a pneumatic power source. Power amplifiers are required to amplify the incoming low powered signal corresponding to the position, velocity, acceleration or the joint commands, usually in the form of electric signals. This simply amplifies the weak incoming signals to the level which can directly be used to drive the actuators. Servo motors or simply the motors takes the varying power input corresponding to the desired commands and follows the commanded trajectory. Servo motor output is further transmitted using the gearbox, belts or chain drives to finally drive the robotic arms. Each of these modular blocks dissipates some energy in the form of losses. Characteristics of an actuator. To meet the competitive demands of the industry, the actuators required to build any industrial robot should have the following characteristics. Low inertia of the armature. The armature is one of the heaviest part of any motor as it is made up of soft iron core, copper windings as conductors, and in case of DC motors, it also carries a commutator on its rotating shaft. This eventually leads to a high moment of inertia of the rotating shaft. It is desired to have a low moment of inertia so that the shaft can quickly pick up the speed and can be stopped precisely when desired. A low moment of inertia shaft is expected to have a good joint trajectory following and precision. The figure to the left shows a coreless armature of Maxon DC motor which is having a very small moment of inertia. High power to weight ratio. As any link of a serial robot carries the weight of the actuator that drives the link next to it in the serial chain, having more weight of the actuator would eventually cause more torque to come onto the joint that drives the link and actuator pair. High torque at the joint would eventually consume more power. Therefore, having a high power to weight ratio of the actuator would effectively reduce the power consumption and the total weight of the robot. Possibility of overload and delivery of impulse torque. A robot should be safe against any collision of its link to the object in the environment or any accidental overload in its payload. So, the driving actuator is expected to take up any such overload. In the case of an electrical actuator, it should be suitably designed or selected to carry a short overcurrent, and its shaft should not structurally fail due to these short overloads. Capacity to develop high accelerations. Most of the industrial robots run at a very small cycle time due to high production demands. This requires the robot to be fast and driving actuators to be capable of generating high accelerations. Having high power to weight ratio and low inertia surely helps in achieving this requirement. Wide velocity ranges. Industrial robots are designed to be used for a variety of tasks. It ranges from a slow welding or a painting job to high speed pelletizing job. Having such diverse set of applications in any flexible manufacturing setup in any industry requires its robot to be capable of generating a wide range of velocities. High positioning accuracy. Even a small error in the angular or linear position of the joints of any industrial serial robot would cause a high accumulated error in the end effector position. So the actuators for any industrial robots should have a very high positioning accuracy. Good trajectory tracking. Most of the jobs that a typical industrial robots do are point to point in nature, like a pick and place task, spot welding, etc. And having a slight deviation from the planned trajectory can be taken care of easily while programming. However, jobs like arc welding, painting may require a very good end effector trajectory tracking capability. These end effector tool trajectory demands call for a good joint trajectory tracking capability for its actuators.